Alright, so today we're learning a different technique. It's called integrating using trig substitutions. So let me explain the idea. The main idea roughly. It goes like this. The trig identity sheet, the famous one, I'm sure you have one, that has a collection of all the famous trig identities, has in particular some of them that are of special interest to us today. And they look like this. Let me back up a second. They look like this. Sine square of x plus cosine square of x is equal to 1. Of course, those can be rearranged to say, for example, that sine squared of x is equal to 1 minus cosine squared of x. And there are other versions. For example, 1 plus tangent squared of x is well known to be a secant squared of x, etc., etc. So the powerful way to look at these identities is in what they do, what they tell you. Let me tell you a little background story. You should begin to think and be sensitive to the idea that monomials behave differently as compared with binomials. Monomials and binomials are not the same thing. The world of binomials may look like this. 3 plus x, and if you had to take that to the 4th power, for example, you'd have to expand that. Be there a while. The world of monomials looks differently. If I have 3x and I have to raise this to the 4th power, well, it's much simpler. That would be 81x to the 4th. You could do that in one line. Monomials play very, very nice with exponents. Here, I'll give you another example in case you're not convinced. The square root of 9 plus x squared, what could that be? Well, who knows? That's a binomial, but if you take the square root of 9x squared, well, that's easy. It's just really easy. It's just 3x, assuming x is positive. So monomials play nice with square roots. Binomials do not play nice with square roots. And the list goes on and on and on and on. Binomials don't play nice with quotients. Monomials do. Here, if you have 9 plus x squared divided by 3 plus x, it's not that easy to just start canceling things. But if you had monomials, 9x squared over 3x, monomials, oh, it's a piece of cake. You just cancel them this way. Binomials don't play nice with division. Monomials play very, very nice with division. The list goes on and on and on and on. Binomials, good luck. Monomials, easy like cake. So the main idea for trig substitutions is to turn a lot of these expressions that are binomials. For example, here on the right hand side you have a binomial. You have 1 minus something squared. Binomial. But the trig identity sheet tells you, hey, you can exchange that for a monomial. And so on and so forth. Here you have 1 plus tangent squared. That's a binomial. But the identity sheet says, hey, you can exchange that for a monomial. And when you start to see it this way, you become incredibly powerful. That's the main idea, to make use of this notion that you can exchange binomials for monomials.